Part 4 of Unit 6 is about molecular geometry. The electron domain geometry that we learned in the last section doesn't always describe the geometry of the molecule because it's taking into account unbonded pairs, not just bonds. Molecular geometry describes the shape of the molecule using only bonded domains. So another way of thinking about it is electron domain geometry shows all the places bonds could go, and molecular geometry shows what the molecule actually looks like. If there are only two electron domains on the central atom, they're going to move to opposite sides of the atom. They're going to be 180 degrees apart, and there's only one molecular geometry possible, that's linear. For a molecule that has three electron domains, there are two possible molecular geometries. First one is trigonal planar, if all the electron domains are bonding. So if we've got three bonds coming off the central atom, they're going to have a bond angle of 120 degrees. And if one of those domains is a non-bonding pair, that shape or that molecular geometry is going to be bent. Now, this unshared pair of electrons is going to cause these to get pushed closer. It's going to be less than 120 degrees for that bond angle. If there are multiple bonds present, like double and triple bonds on one side of a molecule, they put a greater electron density on that one side of the central atom, and they're going to affect the bond angles more than unbonded electrons will. So if we go back to a trigonal planar molecule, if we had a double bond on this one side, what that would cause this double bond would cause these two single bonds to be pushed even closer together than if this double bond was an unshared pair of electrons, because it's 4 electrons instead of 2. For a molecule that has 4 electron domains, there are 3 possible molecular geometries. If all of the electron domains are bonding pairs, it's called tetrahedral. It's trigonal pyramidal if one of them is a non-bonding pair. So it's a triangle pyramid. And if there are 2 non-bonding pairs, it's called a bent shape. That's similar to water. Now, in a tetrahedral molecular geometry, the bond angle is 109.5 degrees, but as we replace bonds with unshared pairs, those bond angles are going to decrease because they're getting pushed closer together. For a molecule with 5 electron domains, there are 4 distinct molecular geometries. It's trigonal bipyramidal if all of the domains are bonded. So we've got these 3 in a plane and one on top, one on bottom. Those are called the polar bonds. If we have one unbonded pair, it's called a seesaw shape. It sounds unscientific, but it could be a molecule rocking back and forth like a seesaw. If there are 2 unbonded pairs, it's T-shaped because it looks like a T. And if there are 3 unbonded pairs, it's ugly placement, but if there are 3 unbonded pairs, it's linear. We've gotten rid of the 3 bonds that were in the same plane, and all that's left were the polar bonds, so it's just tipped on its side down here. And I'm done trying to draw ugly Lewis structures for you, but if there are 6 electron domains, there's going to be 3 possible molecular geometries. If all the electron domains are bonded, it's octahedral. If there are 5 bonds and 1 unshared pair, it's called square pyramidal. And if there are 4 bonds and 2 unshared pairs, it's called square planar. Your question for this section use an appropriate Lewis structure and determine the correct molecular geometry for ammonia, NH3.